Hello everyone, I am AQM Sazzad Sayyed presenting our DLD project digital log with voice recognition option by synchronizing MATLAB and FPGA. I'm going to present the MATLAB part of the code, and my team member Shakib Mahmood, he will present the Verilog part of the code. Well, in the MATLAB part, what we did is just we used three separate M files. One is the function file, and the two new project and untitled 3.m. These two are M files. Using the new project file, what we did is acquisition of sound. For acquisition of sound, what we used is audio recorder function, where this in this audio recorder function actually creates an object which we have named record object 1. Similarly, using this audio recorder function, we have taken 6 separate sounds to make our archive. This 8000 in this audio recorder function denotes the sampling frequency. It's 8. This denotes the number of quantization levels, and this one denotes number of channels. So here we have used 8000 sampling frequency 8000 per second. 8 is our number of quantization levels, and 1 is our number of channels. We have taken sound through only one channel. Here, using the record blocking function, using the record blocking function, we called the record object 1, and this record blocking function does is that it records sound for this 2 seconds. Well, at the start of the sound, we display the start speaking when the user is supposed to start speaking, and then when after the 2 seconds, when the record blocking function stops recording sound, we display the text end of recording. Similarly, we have taken 6 separate sounds: record object 1, record object 2, 3, 4, 6 and 7. These 6 sounds we have taken to create our archive. These 6 sounds, in order to save sounds into files, we have in WAV format, we use get audio data in order to get the data from various record objects, and then we store them in variables called my recording 2, my recording 3, etc. Then these are the file names. We are going to save the data in file names. We are going to save the data, and finally we write the data using audio write function. What this audio write function does is that it writes the sound data taken from my recording into file name, and likewise from my recording 2 into file name 2, and similarly. Now next comes the voice recog 2 part, the voice recog 2 function. This function is actually the main part of a MATLAB code, which what it does is that it processes the sound and gives us the correct output. Now in this voice recog 2 function, what we did is that using audio read function, we first stored the data, restored our data from the archive, and stored in various variables called file name 2, etc., etc. and this fs is actually the sampling frequency. Then next, we did is that we stored all the data data from the archive and also from the user input sound into 17 column matrix, which has approximately 16,000 rows. And then next comes the first Fourier transform. This NFFT, it shows actually it is the number of points for our first Fourier transform. This FFT function, what it does is that it does the first Fourier transform along the columns. This one denotes it directs the FFT function to do the first Fourier transform along the columns of this Y matrix. This f is actually the frequency. This f is actually the number of various frequencies of our sound that are contained in our sound. Then what we did is that in this part we took we have to create a fingerprint. For that fingerprint, in this part we created a matrix of frequencies with 20 highest frequencies, and then we kind of averaged them to create our main fingerprint. And with this fingerprint we try to find the correlation coefficient of our user input data, and this Z2 gives us the correlation coefficient of our user input data with the fingerprint, and this Z1 is actually gives us the correlation coefficient of the fingerprint with all predetermined data, which is we already know that the predetermined data is from the correct user. And then what we do is that we compare the maximum correlation coefficients from these Z1 and Z2 vectors, and if that correlation coefficient is within a certain limit greater than 0.78 and smaller than 1.27, then we return Q equals to 1, which denotes the log has opened or the correct user has input data, or otherwise Q equals to 0, which denotes the log is not opened or the correct user hasn't input data. And finally we come to the untitled 3 function, which is actually the m file to call them, which is actually the m file which takes the data from the user, saves it in a file called testrecord5.wav. Well, and then what we do is that calling this voice recog2 function, we have calling this voice recog2 function automatically invokes this voice recog2 function, and then if the correct user has input the data, then A gets 1 or otherwise A gets 0. If A gets 1, then we display log opened, otherwise we display wrong voice. If A is going to be equal to 1, then the user has to input a password to open the log, or if the password is right, then we display log opened, or otherwise we display wrong password. And finally, if the A is not equals to 1 or A equals to 0, then it is wrong voice, and the user has to input 3 separate passwords. Each of the passwords has to match to each of those 3 passwords, they have to match with these 3 passwords already given. Only then the log will open, or otherwise it won't. And finally, to assist the Verilog part of the code, here we have we have created 2 separate text documents, new text document 1 and new text document. If A is equals to 1, then in the new text document 1 will be written, and if A equals to 0, if A equals to 1, then in the new text document 1 we write A. If A equals to 0, in the new text document 1 we write 0. And when A equals to 0, in the new text document file we write 0, and when A equals to 0, in the new text document file we write 1. And this marks the end of my part of the code, and I request Shakib Mahmood to describe the Verilog part of the code. Thank you.
So thank you, Sazzad Sayyed, for giving me the floor at last to describe the Verilog code. Now the Verilog part is quite simple comparing to the MATLAB part. Here I have not done nothing much. I have declared 2 variables Q1 and Q2, and these 2 variables will serve as markers for writing in our text files. Now I want to light the LEDs, so I will mark them. I am now declaring them. Now I am also interested in watching the result in 7-segment display, so this part is for the 7-segment display. I am using read mem for reading from the new text document. Now, as we know that readmem uses a vector to write its result, or if I say it another way, it reads from the text document and writes in the vector. If you skip this part, readmem probably wouldn't work. Now I want to assign this a1 in our previously declared variables. And here is an interesting fact that if you write this part outside of the begin and end, this will not work. So this is a part of warning for future users who will take lessons from this. And here is also another part that the variable will read the data after a new it encounters a enter in the new text document. If it doesn't encounter a enter, it will not write anything, or it will write probably garbage. And this function is readmem, so it will write 1 or 0. Now the next part is particularly simple. I have always block where I called q1 and q2. I have a condition. If q1 is true, then it will probably show 0, and if q2 is true, it will probably show 1. And this is because if, as our friend Sazzad explained before, that if the lock open is being opened, the new text document will be written 0 and the new text document will be written 1, and if it is not open, then the vice versa will happen. Now this is this part here concludes our Verilog part. Now I will like to talk about something that I wouldn't really feeling comfortable right now, that is our faults or our shortcomings in this project. This project of ours works 70% of time, and the other 30% time it fails because of the noise factor. And as we are in 3.1, we haven't yet learned about more details about noise cancelling. We tried a few things, so if anyone is working about this, they can use our experience. We tried about butterscotch filter, butter filter, and when we take the band gap, there is always noise there. You can reduce other noises outside the band gap using butter filter, but inside the band gap you cannot reduce the noise, so the noise always remains. Then again, we try to take the voice of the surroundings as noise and then later subtract them to get a noise free sound. But as we know, as you have already realized, that noise varies from time to time. Noise varies from time to time. Sorry, I have just a little mishap there. Okay, so if you want to remove these problems, what will you do? So my suggestion is you may use hidden Markov model, because this is the model this is the algorithm basically which is often used in this type of line. Now thank you for listening patiently, and hopefully I have offered you something so that you could be benefited from. And sorry for my bad English, I am not a native. Shakib.
Voice matched. Now we put the password. Lock open. Now I go to
Reloading.
quarters to reload the circuit.
Reading from these MATLAB data.
We see that here is 1.
This one is of previous hour matching. Now Verilog will read it. Over here.
Okay, then
For not matching.
run it. Shakib. Wrong voice.
Give the password. Now as you press wrong voice, you will have to bypass through 3 production gate. Then again it's wrong. Now,
We see that the input here is 1.
because of our previous encounter, reloading again from
You should be a detective.
আমি কেমনে করব আমার আজকে নিজের কাজ করা লাগবে
আমার এই টার্মিনাল
তোদের কাজ বল কাজ তোদের আটটা আমার
টার্মিনাল পরে আমি HTML কি মনে সেভাবে
যাদের বেসিক কারণ
now this should show 0 starting
And we found 0.
no match.